energy. That's what we need to deal with in this video. Because obviously you need energy in your bodies to function. But everyone needs energy, but yet everyone can get energy in varying ways. There's no one, this is the answer of how to get that. So let's take a look at what energy is in this video. Energy comes in varying forms. Now, when you're eating, you're ingesting energy. That's the whole idea, is the nutrients and the energy. So how everyone gets this energy will vary depending on your own body. If you look at elite athletes, so someone running the Boston Marathon, or someone participating in the Tour de France, we're talking very high-level elite athletes here. They all have very specialized and very strict dietary regimens leading up to those events. Now, those individuals, they'll compete to win those events, the very high elite athletes. They're on training regimens for weeks and months ahead of time. And their nutrient intake is going to have a set schedule depending on what their training regimen is. And then you might have a different nutrient intake after training to help recuperate the energy. And then you might have an even different nutrient intake the day of the race. The idea is these athletes and their nutritional coaches and everyone else that supports them, they've gone through and figured out what works for that individual's body. And that's become a multi-billion-dollar industry, not just the elite athlete, but for anyone that's participating in sports, or anyone that's doing any endurance athletes. Because if you've ever looked for something that could be a nutrient recovery after workout, or a recovery drink or powder or food after an exercise routine, those have all been specially crafted based on research to try to get you that energy back as well as replenish your nutrients. So what is all this energy? Well, energy in the general sense is either kinetic or potential. So kinetic energy, that's the energy of motion. While kinetic is going to be moving along, potential energy is the energy of stationary. When you're at stationary rest, you still have energy, but it's just not being converted into movement. So think about someone that's about ready to start a race. All that energy is in their body. They're ready to go. That's potential energy. Once they start moving, that's now kinetic energy. They're utilizing the energy to create movement. Another example could be a waterfall. The water at the top is full of potential energy because it has all that height. But as it falls, that's kinetic energy, the energy of movement. Now, as long as you don't hit anything on the way down, that water hits the bottom, and that force that's exerted at the bottom, that's the energy that was released as it fell down the waterfall. So potential and kinetic energies. We have both, and we utilize both in our bodies. But really, when you think of it from a cell level, a tissue level, what are we talking about? We're talking about ATP, adenosine triphosphate. That's really the energy source that our cells utilize when they're releasing the energy from the bonds. So we have to somehow get this energy, this ATP. So when we start thinking about that from a nutritional standpoint, the foods you eat have energy stored. But then also you have to think about from the fact that in your body you have stored energy that you can release to perform activities. These activities could be you physically moving your body, or it could be the activities of your cells going through reactions to create different metabolic processes. Regardless, you need energy to perform both those types of activity. So when we look at a food label, you'll see calories are listed. You'll see protein and carbohydrates. You'll see lipids or fats. All this information is there to try to inform you about what is in that food and what you're putting into your body. Now, typically we're looking at kilocalories. A kilocalorie is 1,000 calories. For nutritional information, vast majority of this, when you say the calories on a label, those food labels are actually in kilocalories. It's just the way the whole industry has kind of set up and worked. So what that actually is 1 kilocalorie is the amount of energy that was needed to heat 1 kilogram of water 1 degree Celsius. And you're saying, well, what the heck? Basically, you burn the food. The heat that's released will warm the water. So the amount of calories in a certain amount of food is determined by how much heat the water absorbs. And it's set for 1,000 kilocalories will raise 1 kilogram of water 1 degree Celsius. So let's put that into terms that make sense more for proteins and carbohydrates and lipids. Your proteins and your carbohydrates are going to have 4 calories per gram of energy. The lipids, or the triglycerides, are going to have 9 calories of energy per gram. Now I'm saying calories, but again, remember that's actually kilocalories because that's what we're using for nutrition. So it's 4 kilocalories, or according to food labels, calories, for proteins and carbohydrates, 9 kilocalories per gram, or on food labels, calories, for your lipids. We're thinking, hold on, that means we have lipids are more calorie dense. True. Lipids will give you more energy per gram. But the problem there is they don't necessarily give you the nutrients per gram. We'll get to that in a second. So when you look at the food labels, think about that in relation. If something's high in lipids, it's probably higher in calories overall. Things that are higher in protein or carbohydrates won't necessarily be as high in calories as something higher in lipids per gram. So if you're looking at the food labels, keep that in mind. The USDA has a whole huge food database that's great for looking at every single food out there, what the nutritional background is of that food. So if you're really looking to do a deep dive, take a look at that database. Every food you might want to ingest will have this information in that database. Now, all this energy we're talking about ingesting, what do we need it for? We're building our bodies, not to mention movement and metabolism and basic daily functionality for that matter. But let's just build for a second. When you take atoms, molecules, build to organelles, the pieces that make up a cell. From cells, you can then make tissues, like muscle tissue. You can make epithelial tissue. From those tissues, you can then make up organs. Organs make organ systems, think digestive system, cardiovascular system. And then eventually all those organ systems make the organism, us. Which means we have a lot of energy stored in all of our organs and tissues. All of that was built because of energy that was input. Now, do you want to break that down? No, you want to keep it intact. But that's just going to show how much energy was needed to make every single tissue, organ system, cell in your body. They all needed energy to create the bonds to build from those small atoms all the way up to the whole organism. And where did all this energy come from anyway? All the energy we utilize originally comes from the sunlight. You're saying, well, hold on, we aren't photosynthetic. We can't just absorb sunlight. No, we can't. But plants can. And everything we eat is either plant-based Or if it's animals, they ate plants at some point. So think about it this way. The plants go through photosynthesis. Photosynthesis is going to take carbon dioxide and water, plus sunlight, and that will then go through the process of the chemical reactions and produce glucose. Glucose, hey, I know what that is. That's what we use. That's energy. That's sugar. We will use it eventually. But it's that glucose that's in the plants that either we will ingest and then break down by eating plants, or those plants are eaten by the animals, whether it be fish or seafood, whether it be poultry, chicken, turkey, whether it be beef from the cows. They'll eat varying forms of plants. They'll take the energy in, they'll convert the energy into their forms, and then we utilize the energy that was in their forms. So regardless, our energy is coming from the sunlight and photosynthesis. So as humans, we take in that glucose. Glucose is going to go through cell respiration or cellular respiration. What that is you'll take that glucose molecule, you'll go through a couple different chemical processes. When I say a couple, I mean quite a few actually, but we'll get to that later. You'll go through these processes, and eventually, between three main steps, we'll produce ATP. So as we're going through the first step, cell respiration, we're just starting out. Glucose will go through chemical processes until you make pyruvic acid. Now that can be taken into the mitochondria and then go through another process, the citric acid cycle or the Krebs cycle, or several other names it has. It'll then take that pyruvic acid, acetyl-CoA, and go through and produce more energy by breaking the bonds further. And eventually it goes to the electron transport chain, where you're going to take all the electrons, strip those off, and produce even more energy. Now that's the very oversimplified version of that. We'll get a little more into that in another video. But the idea for now is just keep in mind, we'll take that glucose and then through processes upon process, we'll strip down and break down all those molecules to release energy into our bodies. That energy is what we use to power our metabolism, power our movement, basically power our whole bodies. So it's important to make sure balancing our energy intake with our nutrient intake. Because you want foods that are dense in nutrients, but also have a certain amount of energy. So we're looking at foods that are called high quality foods or nutrient dense foods. Those are the foods you want to ingest. In comparison, the ones you don't necessarily want are the empty calorie foods or empty calorie beverages. Now sure, everyone has those occasionally, it's not the end of the world, but you don't want to build a diet around those empty calories because you'll ingest a whole lot of energy without getting the nutrients you need. And that extra energy can be converted into adipose tissue or fat to be stored. So you've got to be careful about how we balance these out. Some examples. Fruits and vegetables are great at being nutrient-dense sources without a huge amount of calories. Look at an apple, for example. Apples are high in fiber, they have plenty of antioxidants, and they're high in vitamin C. Great to have. Now, do you want to have 10 apples in a day? No, but it's a good fruit to mix in daily or every other day or every couple days. But it's not the one you have to have. There's numerous other fruits and vegetables as well. The idea is to get some variety and mix things up. Some other things, lean meats. So we're talking about seafood, poultry like chicken, turkey. You're looking at getting a mixture of nuts in your diet. Getting a mixture of various different eggs, oils. Now, thinking, okay, oils, that's fat. Yes, but you do need to have a little bit of that mixed in. But the key is healthy fats. So looking at what are healthier oils to ingest versus the ones that are full of trans fat or full of saturated fats, heavy on the saturated. So looking at, again, fruits and vegetables, lean meats, looking at eggs, dairy, fat-free or low-fat. When you're saying, well, I like some of the stuff that's full fat. Okay. There's research saying that not a problem having some, but moderation. The key is moderation if something is a heavy fat or heavy on the calories, but not as heavy on the nutrients. It's all about balance. That's one of the biggest things. You have to learn what your body likes, what your body takes, how to balance off your nutrient intake with your energy intake. So we'll get to more of this in future videos. But until the next video,